Hi everyone. Today we'll be starting a new chapter called probability, and I'm sure you have studied probability prior to this, and you have an idea about what probability is, what it entails, what's the idea probability. So this is an introduction video. I want you to get a gist of it. We'll be doing some questions, some tricky ones, some simple ones to start off with, and we'll build a base from there and then move forward from there. So probability, I'm sure you've studied, probability is basically tells you the likeliness of an event, right? The likeliness of the occurrence or the occurrence of occurrence, right? How likely something is to happen, right? Let's say flipping a coin, right? Flipping a coin, you flipped a coin. So what's the probability of getting heads or tails, right? Heads or tails. Classic example, right? You have a dice, right? What's the probability that you'll get, one facing to you, something like that, right? You have three different T-shirts. What's the probability that, or you have three different T-shirts and three different shorts, and what are the probability that you'll pick a specific T-shirt and a specific short? So something like that, all those things. So those are all related to probability. Obviously, yes, probability can be, a little abstract, especially if you go into detail and if you study probability at much deeper level. But for now, we'll stick with something where we can work with definitive probabilities and solve questions based on those situations. So let's start with a very simple understanding of deterministic experiment, right? So the deterministic experiments can be understood as something when they're repeated under identical conditions produce the same result, right? So this is an example from a chemistry class, and I'm sure you have a sodium hydroxide and a hydrochloric acid, and it's going to give you sodium chloride, which is your table salt, right? Now, no matter how many times wherever you do this reaction, whenever you do it, you're going to be getting sodium chloride regardless. You know that this is for certain, table salt for certain. It's certain, right? Certain means 100%, it's 100%. So the probability of getting, NaCl, is 1, or you can say 100%, like I said before. So it's a certain event. You know it's going to happen every single time. So now let's move out. Let's move on to what we call random experiments. So random experiments is a process in which results in an outcome, which is one of the various possible outcomes. So let's say flipping a coin. You have your heads and tails, something like that. Your dice, all those sorts of things, where the probability lies between the probability will lie between 0 and 1, right? Either it's going to be impossible or it's going to be certain, right? That's your spectrum that you're going to be working with here. So let's look at a few examples. What are some examples of random experiments? Like I mentioned before, we have tossing a coin, tossing a pair of coins, again and again and again. Maybe tossing three coins in a row and asking what's the probability that we'll get 2 heads out of the 3 or all heads. Rolling a dice, rolling a pair of dice, same thing. Getting 1 6, getting the sum should be equal to 6. Taking out card out from deck, you have 52 cards in a deck. What's the probability that it's a suite of hearts, something like that. Again, taking out a ball from a bag, very classic orthodox examples, right? And these are kind of the examples that you're going to be seeing in your exams as well. Nothing's going to be out of the ordinary. It's going to be some situation which you've seen more often than not. Okay, so let's talk about something called sample space. Now, oftentimes, these are some just important terminologies I am discussing. because what happens is we start working, we start solving the questions, and we see these terminologies, and then we kind of forget what we're trying to get as a final answer. So I just want to revise these terminologies so we are aware, right? So sample space is, as the definition says here, it is the set of all possible outcomes, right? It's basically a way of if you've done your sets, the chapter of sets, unions and intersections. You create a sample like this with your curly brackets like this, and then you list out all the possible situations. So in this situation, the probability or the sample space for flipping one coin, well, that's either heads or tails, right? It's as simple as that. When you're flipping two coins at the same time, well, you can have heads, heads. You can have heads, tails. You can have tails, heads. My bad. Let me erase this. You can have tails followed by heads, like this. Or you can have tails and tails. So now you have four possibilities. The sample space for rolling a dice, well, you already know it. It's any number between and including 1 and 6. So 1, 2, 3, 4, 5, and 6. That's about it. But that's how it's denoted. It's called S equal to, and then you have your curly brackets around it. Okay, so let's look at something a little bit with more of an example to give a better intuitive sense of what I'm talking about. Let's take that we're rolling a dice. We're rolling two dice. Okay, two dice. Dice. Okay, the plural of dice. So let's say this is the first dice and this is the second dice. Okay. So we see that there are 6 and 6. There are a total of 36 total possibilities. Now, if you want to create hypothetical situations out of here, well, we can do that. That's not that difficult. Let's say we want to figure out what is the probability that we'll be getting the same number on both dice. Well, we can see right here, this is 1, 2, 3, 4, 5, and 6. Well, there are 6 possibilities, and there are 36 total possibilities that can occur. So our probability of getting the same number is 6 by 36, or I can call it 1 by 6. That's our probability. That's our likelihood of getting the same number, right? Let's say, what is the probability of getting only one 2 on the face? Only 1 2, right? The other can be any number, just can't be 2. Well, in that case, you have this one, this one, this one, this one, this one, this one, and all those in this row, right? All the ones in yellow. So in that situation, well, you have 1 2 3 4 5, 1 2 3 4 5, a total of 10 possibilities out of 36 possibilities. If you want to simplify, you can simplify it down to 5 by 18. That's the likelihood. Another situation, a different situation you want to take a look at this point can be, what is the probability that the sum on both dies will be, let's say, equal to 7, right? So anything that can equal 7, so this can equal 7, this can be 7, 4 plus 3 is 7, 3 plus 4 is 7, 2 plus 5 is 7, 6 plus 1, and 1 plus 6 is 7 as well. Is anything else going to add up to 7? No, I'm afraid not. So we have 1, 2, 3, 4, 5, 6. Again, 6 by 36 simplified to 1 by 6. So I hope you get the understand of what the sample space helps us do. It kind of maps out the different possibilities for specific events. Right? Like in the blue, we had the events of the same number on both dice. On yellow, we had the probability that there's that 2 appears only on one die, and green is that sum of both numbers is equal to 7. Okay, so how can we define probability now? Right? Probability, if I had to define it, I don't think I need to, but if I had to define it, well, it'll just be, probability of an event, right? Is the probability or the occurrences of the wanted event, by, it's kind of like a ratio, you can say, or like a fraction, right? By the total possible occurrences. That's how it is, right? That's how it's going to be. Fair enough? Okay. And another criteria which is quite the obvious, so the probability is always going to be between 0 and 1. It's as simple as that. We know that. That's how it works. Okay? Right? Okay. Very simple question. You can give it a shot and let me know. Well, we have a pair of fair dice. That's important because we have to know that they're unbiased, right? Either you're gonna hear fair or you're gonna hear unbiased. Unbiased. That's also an important word. Unbiased means fair, right? The possibility of getting 1, 2, 3, 4, 5, or 6 on rolling a dice is always gonna be equal to each other, just like flipping a coin. It's equally likely to get 50-50 heads or tails. Same situation here. Okay, so a pair of dice is rolled, find the probability of getting a total of 6. Well, there are multiple ways of solving it. You can solve it intuitively. There's no formula to solve it. A simple way is, a shortcut that I can maybe share, because a lot of the times you are going to face questions with rolling dice. You're going to have 2 12 like this. 3 and I think 11 as well, 3, 4, 5, 6, and then 7 like this, and then you're gonna have 8, 9, 10, and then 11, kind of like this. So the probability of getting this is 6. Probability of getting each of them is 5, 4, 3, 2, and 1. So the chances, obviously, the only way you can get 2 is having 1 and 1. The probability of getting, the only way of getting 12 is 6 and a 6. Well, the only way you can get a 6 and a 6 is that's like 1 out of the 36 total possibilities, right? So this is kind of like a U-shaped, pattern you can think of. It's like a shortcut, right? It is a shortcut. And then you can see, okay, if I want to get a total of 6, so that can only happen 5 different ways, and you can kind of work out the math. Well, either have 1 and 5, 2 and 4, 3 and 3, and 3 and 3 and 3 and 3 is the same thing, right? And then I can have 4 and 2, and then I can have 5 and 1. Okay, so that's a total of 5 ways. That results in 5 by 36. That's my answer. And you can go back on the table. You can see. I'll do it in red. We have, oh, so sorry, let me activate the pen again. We have 5 and 1, 4 and 2, 3 and 3, 2 and 4, 1 and 5, right? That's what we have. So that's what we had here as well. Okay, next question. So we're told that there are 3 distinct numbers that are to be selected from 100 natural numbers, right? Basically means 1 to 100. Okay. The probability that all the 3 numbers are divisible by 2 and 3. Well, here's a trick, and I'm sure, and I'm not sure, but assuming that you don't know it, that if a number is divisible by both 2 and 3, it's a multiple of 6. Multiple of 6. That's important to know, because that's going to save you loads and loads of time, right? It's essentially, what you can do is you can just find the LCM of 2 and 3. Basically, that's what I'm doing, right? And if you do, recall, if you guys have ever learned the divisibility rules, like, for 2 it should be even, for 3 the sum of the numbers should be divisible by 3, for 4 the last two numbers have to be divisible by 4. You must have come across this as well, right? If it's divisible by 2 and 3, it's also divisible by 6, or it's a multiple of 6, as simple as that. Well, how do you figure out how many numbers are divisible by 6 from between 1 and 100? Well, either you can use arithmetic sequences, arithmetic sequences. You can start as your U1 as 6, and then you can keep going forward and forward and forward, and you'll get the idea. Or what you can do is you can divide 100 by 6, okay, and you get the you're gonna get some 16 point something something something, right? You only care about the 16 because that's all that matters, right? So you're gonna have 6, 12, 18, 24, all the way down to 96. That's going to be our last term, and then their other term is going to be 102. Well, 102 is obviously more than 100, so we only care about these terms, right? And you're going to end up with 16. So we know that there's 16 numbers that are divisible by both 2 and 3, or we can say that they're a multiple of 6. That's also, an efficient way to work on it. So now we have 100 numbers, and we have to choose 3 distinct numbers. Well, if we're going to have to choose 3 distinct numbers, let me go on the next page, right? That's essentially saying we have to do 100 C3. We can't do 100, we really can't do 100, P3, right? We have to do 100 choosing 3 because it's distinct. It's kind of like taking people, right? People are, if there are 100 people and you're choosing 3 people, you can't do 100 P3. You have to do 100 C3, right? You can't do 100 P3. That's not possible. So that's our total ways or possibilities of choosing distinct numbers, 3 distinct numbers. 3 distinct numbers. That's the best way. Now, that's the total ways, right? Now we have to find how can we choose out of the 16 numbers, how can we choose 3 distinct numbers that are a multiple of 6? Well, same idea here as well. It's going to be 16 C3. It's as simple as that. 16 C3. Number of ways of selecting multiples of 6, right? So how do we find the probability? The probability is going to be 16 C3 by 100 C3. That's it. That's all it's going to be. So let's simplify it a little bit. What are we going to get? We're going to get 16 factorial by 14 factorial by 3 factorial. Oh, sorry, 13 factorial, right? And then we're going to have 100 factorial by 97 factorial by 3 factorial. Well, 3 factorial by 3 factorial cancels, and we're going to be left with 16 times 15 times 14, and we're going to have 100 times 99 times 98. And if we simplify it, we'll get our final answer. If it's in a calculator section, it's going to take like 2 seconds to do it. If it's not, you know how to solve it now. Another way of doing this would have been, if you look at this carefully, if I just break it apart, right? If you look at this part, and then this part, and then this part, right? You can think of it as, okay, I know there are 60 numbers between 1 and 100 that are divisible by 6, or that are multiples of 6. Well, I have 16 options to choose from out of 100 numbers. So that's the probability of picking the first number out of the 3 distinct numbers. After that, I'm going to have 15 numbers remaining and a total of 99 numbers remaining. After that, I'm going to have 14 possibilities, followed by 98 total possibilities. That's another way of solving it. If you see, I'm getting the same exact thing. So this is how nicely or how perfect, how ideal situation wise it works, like the math checks out. You can see either I use a formula of 16C3 or I do it intuitively here, like how I did in yellow. And it checks out. You can see, wow, I'm getting the same exact thing. I could have solved it both ways, but oftentimes when things do get a little bit more hairy, a little bit more complex, solving using permutation combinations is really a lot more easier. I hope that makes sense. Okay. Next option. Okay. Next question. Sorry. We have the letters of the word assassin are written down at random in a row. The probability that no two S occur together is what? Okay, so kind of like an arrangement again, except we have to find a probability. Well, let's start off. How many A's do we? Let's start off with how we would do it if this was just a permutation, a combination question, right? If that was the case, we'll first find the ways of arrangement, and then we can think about the probability part. So we have how many letters? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 total letters, right? So if we have to arrange these letters, how would we do it? Well, it would be 8 factorial ways. But remember, they're repetitions. How many A's are there? Well, there are 2 A's, so 2 factorial. And then how many S's are there? 1, 2, 3, 4, right? 4 factorial. Are there any repetitions with the... So there are 2, 4, and then I and N is separate. So this is the total ways of arrangement. Got it? Okay. So let's simplify this. What do we get? Well, we get 8 times 7 times 6 times 5 by 2 factorial, because I removed the 4 factorial, and this is the same thing as, 4. So this is like 28 times 30. And I'm going to leave it like that. I don't need to simplify it even. Okay? I'll tell you why later. You'll figure it out. Now we have to find out the ways of arranging these letters such that none of the S's are together, right? Well, let's start by that means no S's are together. That means there has to be some alternating pattern. If you remember, again, this is all coming together now. All the math what you've studied from permutation combination is coming in together. And if you feel overwhelmed by these questions, don't worry. The more you do these questions, the more you struggle on them, the easier it'll be to solve them later on. Trust me, it gets easier. And if you're thinking that, oh, I'm just going to skip this part of, permutation combinations and probability, don't think about that, because a good chunk of the questions are actually overlapped between permutation combinations and probability. So don't think about skipping this part if you're feeling underconfident or if you're feeling uncomfortable about it. Get used to it, be uncomfortable. Trust me, it'll get a lot more easier as you move forward. Okay, so back to arranging the letters with none of the two S's are together. So we have your A. Let me erase this. I didn't really like how I started off. So we have A, I, and N. Okay, I don't know why I kept so much space. Let me erase it again. Let me do it really nicely. Okay, so we have here A, I, and N. Now the only reason I'm doing this is if you notice that there are equal numbers of S's and A's. And S's and all the letters that are not the S's. So I have to segregate all A's separately, because if I club the A's together, then the S's are gonna be together, and I can't have that. That's why this is a very specific situation that I'm getting in this question. Otherwise, you're gonna have to look at the different cases and then solve it. Again, approach is the same. It's just that you have to look at the possible scenarios and cases that can occur. That's the only thing that you have to be aware about. Otherwise, solving this question is identical in every other situation. Okay, so we have 5 slots. We have 1, 2, 3, 4, 5, and we have 1, 2, 3, 4. Right? So we have 5 slots and we have 4 S's. Now think about it. Tell me, how do I solve this part? Pause the video and try it out. Okay, so I hope you had, you recalled what you previously learned in permutation combination. Well, you have five options. You have to choose four of them, and the order doesn't matter, remember. So we're going to have 5C4. But that's not all. We still have to arrange the remaining A's and I and N. Let me change the color. So this one, this one, this one, this one. You still have to arrange these letters as well, don't forget. So how do we arrange those letters? Well, it's the same way that we did here, previously up here. We're going to have 4 factorial because there are 4 letters, and we're going to have it divided by 2 factorial because the A's are being the A's occur 2 times. So that's the total number of arrangements we can have where S is not together. Okay, not together. I hope that makes sense. If this is confusing, I highly recommend you check out the arrangements, combinations, permutations, the second, third, first videos of permutation combinations on my playlist. It's available there. Once you can solve those questions, then you can try these questions again. It's going to be a lot more easier, only because 80% of the work that we do is from combinations, and then it's just the last part, which is of probability, right? So now let's wrap this question up. Well, we're gonna have the probability is gonna be 5C4 times 4 factorial by 2 factorial divided by, well, the total weight is just 28 times 30. 28 times 30. Well, 5C4 is basically 5 times 4 factorial by 3 factorial by 28 by times 30. Okay, so this can cancel out. This is going to be 2. This is going to be 2. This is going to be 14. So we have, I'll write it, probability is going to be 1 by 14.
Alright, so final question for today. I want you to give this question a shot. Again, it's a little tricky, but um, if you do, if you are confident with your permutations, combinations, how to work with that, I think this should be something that you can figure out. Okay, so we're told that out of the 27 tickets marked with numbers from 1 to 21, 3 are drawn at random. The chance that the numbers are in an arithmetic progression or a sequence, right? 3 numbers in consecutive numbers, right? Consecutive, or you can sequences or consecutive. It's as simple as that. Okay, right. Let's start. So let's start with the easiest part. What are the total ways of selecting 3 numbers are is from between 1 and 21 is what? It's 21 C3. That's as simple as that. Let's stop right there. So that's guaranteed a few marks for us, right? If we just write this, we're gonna be getting some marks from the IB examiner. Okay, now let's look at the next part. The chances that the numbers are in an arithmetic progression. Well, what's the rule for our arithmetic progression? Remember, the rule is it should be A plus C should be equal to 2B if the numbers are an A, B, and C progression, right? Or B is equal to A plus C by 2, right? It's the middle number, right? The middle number. So now, how do we decide the possibilities, right? Or how do we do a selection round? Well, first of all, we know that A plus C is going to be even. Why? Because 2B is even, right? You multiply any number with 2, it's even, right? That's how it's going to be, right? Okay, perfect. So we know this is the situation right here, right? It means A plus C is even, or either B is even, right? Either B is even and A plus C is also even, right? A plus C is going to be even, but A and C individually can be odd, right? Even this can be individually be odd, right? There are multiple situations, right? So now let me see if I have a next page. Okay, yeah, I do. Okay, so we have 2 options. Either we have the odd numbers, we have 1, 3, 5, 7, all the way down to 21, or we have 2, 4, 6, 8, all the way down till 20. Right? That's how it is. That's what it's going to happen. Right? So, now you have to understand another point is the middle number in this question, right? The B. That is highly dependent on A and C, because A is here, C is here. Whatever A and C is, the B is going to be the number between them. So we just care about getting A and C, and B can take care of itself. Because that's how we're going to solve this question. We really can't, do pick this one as well and then, work with it. That's really difficult, right? So we just have to worry about A and C. If we can get them right, we're set. We don't have to worry about anything else. That's how simple the situation is going to be. So we have two possibilities here now, right? So either we take two numbers from the odd row or the even row, and we should have the middle number in between, right? We should have that we should be fine with it. Okay, and you can take any numbers you want from this set, and you can do some trial and error, and you'll notice that, okay, it does work out, right? So now we have to choose two numbers either from the odd set or the even set, right? So how do we do that? Well, how do we know how many numbers are there? Well, there are 10 numbers here, so we have 10C2, and we have 11 numbers here. Well, you can count them out. You have 11, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. So that's 3 plus 3, 6, 9, 10, 11, right? And the remaining 10 numbers are from the even set. So you're going to have 11C2, or that's what I'm going to add 10C2, right? These are the two possibilities that I have, right? These are the ways of selecting consecutive numbers, selecting AP, right? Arithmetic progression. Okay, let's go to the next page and let's solve it now. So what's going to be the probability? Well, the probability is going to be 10C2 plus 11C2 divided by 21C3. It's as simple as that. Why is it 2? Let me remind again. I'm just selecting out of the A, B, and C. I'm just selecting A and C. My B is gonna be. Well, I'm so sorry for repeating the same thing again. The middle number is going to be, by default, it's going to be between A and C. It has to be, because I'm picking three consecutive numbers, not four, not five, just three. That's why this pattern works out. Okay, so now let's simplify it down. What do we have? Well, we're going to have 10 times 9 times 2 divided by 2 plus 11 times 10 divided by, I think, 2 as well, right? 10 factorial by 8 factorial by 2 factorial, 11 factorial by 9 factorial. Yeah, okay. And then 21 times 19, times 20 times 19 divided by 3 times 2. So I can, kind of add this up. What do I get? Oh, I get 90 plus 100. Or can I simplify this in any way? Yeah, I can remove the 2's, right? So I'm going to get 10 times 9 plus 11 times 10, 21 times 20 times 19, like this. And in that case, I can factor out the 10, and I should have like this. And then I have a 20, because I'm going to add the 9 plus 11, so that's going to give me 20 times 21 times 2 times 19. So this should be 10. So 10 by 21 times 19. Let me just check with my calculator in this point. Okay, and I've missed one part, which is this part. So 7, I missed adding it. So this is a 7, this is a 7, this is a 7. So 17 times 9, I believe, is going to be 70 plus 9, 63, which is 133. Okay, and that should give me a 10 by 133. That's my final answer. Okay, so I hope, with these different questions, that things make a little bit more sense. You get the idea of how I'm integrating combinations and PNC with probability, and that's how it's going to be for a good majority of the situation. Obviously, you're going to have questions where it's not always going to be the situation, but believe me, using permutation combinations, it's a lot easier to solve such questions. Okay, that was all for this video, and I'll be seeing you in the next video where we'll discuss different cases. Well, we're going to have discuss mutually exclusive, independent, geographical probability as well. So yeah, that was all for this video, and I'll see you in the next one. Bye bye.